Problem from this 1997 South African Math Olympiad. I don't know what problem number it was, but I'm using a slightly different constant here. They use 7/2. Okay, I'm using 11/3 just to change it up just a little bit. Same idea. Now, this original form is kind of important. We need to write it like this. The 1 goes here, the 1 or the 2 goes here, because if this digit right here was bigger than 2, say if it was 3, then 3 times 11/3 would make this a larger digit number, or make the resulting number a larger digit number, if that makes any sense. So I should technically be checking this for 1 and 2. I'm just going to check it for 1. Okay, now just an example of why writing it in this form is a good idea. Let's take a look at a concrete example. Let's say we have, say, 1365. Okay, 1365. Now notice we can write that as 10 to the third power, 10 raised to the 3 plus 365. And keep that in mind as you're watching this, because that's kind of important to write it in this form. Now, there's nothing in this about the last digit, which is a little unsettling. But in any event, notice that 365 is less than 1,000, and that's why we write this condition here. Okay? Now, here's what the problem statement says. It says, take 11/3 times the original number. Well, this is our original number. Now, this part's a little weird right here. Okay, we want the first digit to be the first digit here, which is 1, to be the last digit here, right? And so you see what we need right here, this 10b, as far as this problem right here, you can see why it's working that way. 10b, just for this concrete case, but in general this is true, 10b would be equal to 3,650, right? 3,650. All right, and that's what you want, because you want this 1 to be the last digit, right? So 10b plus 1 would be 3651, which is the reverse, right? Or it's pushing this 1 to the last digit. See, such that when the first digit is moved to the end, right? The first digit is moved to the end. So right here, the first digit, 10b plus 1 would be, let me just write it down. 10b plus 1 would be 3651. And that would have accomplished, that's kind of interesting. I didn't think about this. I had to look at the problem solution. But notice here you go. You have the 1 at the front. Now the 1's at the back, right? So that's why we do this part right here, okay? Just a concrete example to show you why we do that part right there. Now the rest of this is fairly routine. I couldn't decide whether or not to write it in this form or this form. This turned out to be the most palatable form right here. So you see what we're looking for right here is we're looking for a 10 to the n that is congruent. In other words, guys, you're familiar with this congruence notation? We need this numerator to be a multiple of 19, and that's what this says right here. This congruent statement right here says that we want the numerator to be a multiple of 19. That is, we want it to be equal to or congruent to 0 modulo 19. But in that regard, we're looking for 10 to the n. We want, and I should say this, another way of saying this is we want 10 to the n to be congruent to 2. Right, folks? Because you see, if 10 to the n is congruent to 2 mod 19, you would get 22 minus 3 is equal to 19. And so you found the smallest n that it's going to satisfy this. Now, and right here, I probably should say find the smallest natural number. You can find them all just as easily, but just to make it simple, we'll just find, this should be the smallest natural number such that this is true. Okay, so we want that to happen, and the rest of this is just modular arithmetic. The way I got started here was, what do we got here? 10 squared. 10 squared is 100, right? So 10 squared, when you divide it by 19, leaves a remainder of 5. So 10 squared is congruent to 5. right, folks? Okay. Now from there we would get 10 to the fourth is 25. I'm sorry, that's a 10 to the fourth. Let me erase that. Uh, 10 raised to the fourth power would be congruent to 25. Right, folks? You can multiply congruences just like you can multiply regular equations. But notice that 25 is congruent to 6, okay? And so on. I won't work the rest of this. It's all, you guys can verify all that. But 25 divided by 19 leaves a remainder of 6, right? And then you would get 10 to the 8th would be 36, but that leaves a remainder of 17, and on and on and on. And when you carry on like that, you end up getting 10 to the 17th, okay? So it's congruent to 2. So 17 is kind of our magical n right here, okay? So what we do is here's our original number, right? So we take it and we substitute. And y'all, by the way, I had to use a calculator right here. It's a nasty. I guess technically you could do this by hand, but actually it's pretty. Dividing by 19 is a pain. Okay, dividing by 19, but I did use a calculator here, and so we get that 10 to the n plus b. All right, now that means we have to add. Did I leave something out here? No. Let's see. 57. Do I have that right? 157. 10 to the n plus b. Yeah, right. 10 to the n plus b is equal to this number. Sorry. That's when we use this choice of n equals 17 right here. I didn't write that down, but n equals 17. Okay. And so 10 to the n plus b is this number with the 1. Notice how I got the 1? Now, when the first digit is moved to the n, we get this resulting number, right, folks? Again, this is our leading digit, right, of the original number, right? All right, now when we move it to the end, we get this right here, okay? So this is the resulting number, using the language from up here, right? We're talking about original number, resulting number, right? And so there we go. So we get this when we substitute 17 in right here. Now notice you're wondering, okay, right, how do you know that's equal to 11/3? Well, I really don't, but I'm fairly certain it must be. Now, one way to get a nice estimate on this is take a look at these leading digits right here. Notice that, let me see if I have some room here. I'll just try it right here. Notice that 3 is less, and this just gives you a crude estimate, but you start to trust the answer a little bit more. 3 is less than 578. I'm taking the leading 3 digits of each of the numerator and the denominator. So here's your 578, right? 578, and then there's our 157. Okay. Now this is clearly between the two natural numbers, 3 and 4, right? 4 times this number would be bigger than the numerator, and 3 times this number would be less than the numerator, right? So you know that 11/3 is certainly between 3 and 4, right? 11/3 is what decimal? It's 3.66 ad infinitum, but 11/3 is definitely trapped between the natural numbers 3 and 4, right? Okay, so folks, this I guess I don't even know what the question is anymore, but it says find anything congruent to that. Mod 19, by the way, would also work. But we answered the question, what is the smallest natural number? What is the smallest natural number? What is the smallest natural number that satisfies that condition? Well, this would be the answer right here, right? When you multiply this by 11/3, multiplying this by 11/3 is equivalent to moving this 1 to the end, and everything else stays the same. I thought that's pretty cool. A challenging problem, no doubt. I wonder how many competitors actually got that. But anyway, so I guess this is quote the answer. There's a lot of questions you could ask. This is quote the answer. And again, it was my bad I should have said find the smallest natural number such that, okay? And this is, as big as this thing is, it is the smallest natural number. It's an unpronounceable number, probably dodecadillion or something like that. But in any event, that's the solution. I hope you enjoy.